Welcome to MRL. In this learning session, we'll be learning about the types of decimal expansions. If we have a number of the form p by q, and if p is divided by q, we get different types of decimal expansions. The different types of decimal expansions are terminating decimal expansion, non-terminating recurring decimal expansion, which are again of two forms, pure and mixed, and the third one is the non-terminating non-recurring decimal expansion. Let us study them one by one. Now the first one is the terminating decimal expansion. If we have a number 2 by 5 which is of the form p by q, and if we divide p by q, that is if 2 is divided by 5, then we get 0.4. 0.4 is the decimal expansion which is terminating, because the decimal place, the decimal part has got only one decimal place. And if you take another example, 4 divided by 125, if you divide 4 by 125, we get 0.032, which is having a decimal part which has got only 3 decimal places. Therefore, these both are terminating decimal expansion. Therefore, the decimal expansion which has definite decimal places is a terminating decimal expansion, and both these rational numbers have terminating decimal expansion. Therefore, the rational numbers have terminating decimal expansion. Rather, the rational numbers are defined as the numbers which have terminating decimal expansions. Remember that. Now, again, if you take some more examples, let us see how the rational number can have any other type of decimal expansion. If you take the number 1 upon 3, when you divide 1 by 3, we get 0.333 and less. It means it is unending. That means 0.33 is unending. It has got indefinite or innumerable number of decimal places in the decimal part of decimal expansion, and this repetition can be represented by 0.3 bar. So the bar above 3 indicates repeating part. The decimal expansion has indefinite repeating decimal, and it is a non-terminating recurring decimal expansion. Therefore, this is non-terminating decimal expansion, and the decimal expansion after the decimal point has only repeating part. Therefore, it is a pure decimal expansion. This is very important here, that the repeating part, this is a repeating part, and it is having what you call only repeating part. Therefore, it is pure decimal expansion. The decimal expansion after the decimal point has only repeating part. Therefore, it is a pure decimal expansion. That means after the decimal point we have got 3333. Therefore, it is a non-terminating recurring repeating decimal expansion, and it is also called as a pure decimal expansion, because after the decimal point only one number is repeating. Only we have the repeating part. Now, if you take another example, 2.2525 dot dot dot, here we have two places, that is 2525 is repeating. Again, after the decimal point we have got only the repeating part. In this also we have after the decimal point only the repeating part, and therefore whether it is 0.3 bar or 2.25 bar or 0.142857 bar are all non-terminating repeating decimal expansion of the form pure of pure form. Now, if you take this example 0.256262, in the decimal part we have got two parts here. 25 is a non-repeating part, 62 is a repeating part, and therefore it is a decimal expansion which has non-repeating part and an indefinite repeating part, and therefore it is called as a non-terminating recurring impure decimal expansion. So the non-terminating recurring pure decimal expansions and the non-terminating recurring impure decimal expansions all represent rational numbers. Therefore, a number which has decimal expansion which is terminating or non-terminating recurring pure or mixed decimal expansion is a rational number. Remember that. Now, the decimal expansions of rational numbers and its parts. Let us understand what does this mean. Now, the decimal expansion, as you know, we have three parts: the integer part, the impure part, and the periodic part. The part before the decimal point is called as the integer part. The finite number of digits after the decimal point is called as the impure part, and repeating part is called as the periodic part. Now, let us take one example to understand this. 6.15323232 dot dot. If you find here in this decimal expansion, 6 is the integer part, 15 after the decimal point is not repeating, and it is the impure part, and then 3232 is repeating. It is the periodic part. And if you see here, the string of digits in periodic part is length of period. Here period of length is 2. And if you take one more example, 0.3333, which is 0.3 bar, it is 100% having only repeating part, and therefore it is purely periodic. If you take the example 0.004000 dot dot, you find here in the decimal expansion decimal part, it has got 0.004, which is non-repeating, and 0 bar is repeating, and therefore it is eventually periodic. It is impure. It is a impure non-terminating recurring decimal expansion. Now if you take this example 0.15323215, in the decimal part it has got 15 which is non-repeating, 3232 is repeating, and therefore it is eventually periodic. Therefore remember, the rational numbers have decimal expansions that are terminating decimal expansions, non-terminating purely periodic decimal expansions, and non-terminating eventually periodic decimal expansion. So remember what type of decimal expansion the rational numbers can have. Now we have irrational numbers, and the irrational numbers are those which cannot be of the form p by q, where p and q are integers and q is not equal to 0. But here the decimal expansion of irrational numbers is, if you observe this number 3.11001130 and dot dot, you find that the decimal part is having a non-terminating non-recurring decimal expansion, and therefore this represents an irrational number. Therefore irrational numbers are the numbers that have decimal expansions which are non-terminating and non-recurring or non-repeating decimal expansion. Remember that. So that is how we can understand the different types of decimal expansions, whether they are rational numbers or irrational numbers, and that is a very, very important study as far as numbers is concerned. And remember, the irrational numbers are all radicals. For example, root 2, root 5, root 6, root 7, root 8 and so on. They are all irrational numbers. Okay, so remember this. And if you find out the expansion of root 2 by long division method, again it will have a decimal expansion which is non-terminating, non-recurring or non-repeating, therefore it is an irrational number. Similarly, pi, although it is 22 by 7, we find that the value of pi is taken as irrational because the measurement of the values of the circumference and the diameter may be irrational. Root 7, if you find out the value of root 7 by long division method, then we find that it is having a decimal expansion which is non-terminating and non-recurring, and therefore it is an irrational number. Remember that. So therefore there are infinite irrational numbers, there are infinite rational numbers, and both these sets of rational numbers and irrational numbers together form a new set called as a set of real numbers. So this is what is about the decimal expansions. And please remember the different types of decimal expansions and which decimal expansions represent rational numbers and which decimal expansions represent irrational numbers, and both of these decimal expansions, whether it is terminating or non-terminating recurring or non-terminating non-recurring, pure or impure decimal expansions, all of them put together form a new set of numbers called as real numbers. So that is what is the study of decimal expansion. Note down in a book for your future reference, study it and remember. Okay, thank you.